Welcome to the educational website on the 5 domains of biomedical informatics. My name is Ringal. I'm currently a graduate in Stony Brook University, completing master program in applied health informatics, and I will guide you through this website. This is a 15-minute video that will provide an overview of the biomedical informatics. The goal of this website is to help you understand each domain and how they benefit the future of U.S. healthcare system. In the homepage, you'll see the introduction of the website and 5 different learning objectives. You can use the horizontal navigation or the sidebar to go any other pages to explore different domains of biomedical informatics, to learn about different applications of each domain and how they benefit the healthcare from different perspectives. Now, let's begin the journey in the field of biomedical informatics. The biomedical informatics is the use of health IT technology to enhance the quality of healthcare delivery and patient safety by supporting the decision-making of both professionals and patients. The biomedical informatics is described as an interdisciplinary field that transforms the biomedical data into knowledge effectively for problem solving to improve human health. In fact, the field of biomedical informatics is complex. It has recently been redefined into 5 different domains, which includes clinical informatics, clinical research informatics, consumer health informatics, public health informatics, and translational bioinformatics. And each domain has impacted how medical staff, researchers, and clients practice medicine. The first domain, clinical informatics, focuses on improving healthcare service delivery, in which clinical decision support system can help clinicians make better decisions by filtering, organizing, and presenting the data. Its application, clinical decision support system, is a tool which combines computable biomedical knowledge, person-specific data, and reasoning or inferencing mechanism to generate helpful information to the clinicians. A clinical decision support system has been defined as an active knowledge system, which uses 2 or more items of patient data to generate case-specific device. This implies that a CDSS is simply the decision support system that is focused on using knowledge management in such a way so as to achieve clinical device for patient care based on multiple items of patient data. Knowledge-based and non-knowledge-based are 2 different types of CDSS. Knowledge-based CDSS is useful in determining drug interaction, and non-knowledge-based CDSS allow computer to learn from past experience and find the patterns in the clinical data. A 2005 systematic review concludes that CDSS improved practitioners' performance in 64% of the study, and CDSS improved patient outcomes in 13% of the studies. CDSS can analyze clinical data for clinicians, provide decision support at the time and the location of the care, provide a platform to integrating evidence-based knowledge into healthcare delivery, and apply rules to patient data using an inference engine. CDSS also can help clinicians identify and avoid adverse care events, streamline the workflow of healthcare to increase efficacy, and prevent the events of improper diagnosis and wrong dosage of medication. As popularity of CDSS is increasing, a better patient outcome and a higher quality of healthcare will emerge in the U.S. healthcare system. The second domain, clinical research informatics, focuses on developing new informatic technologies and management of the new theory relating to disease by sharing big health data, which allow clinicians to use the data for secondary research. Its application, Clinical Research Management System, is a web-based tool to organize clinical research management, which allows effectively communication among study team members, store the information securely, and run real-time reports. As the number of relevant applications increase, the problem of duplication of data and redundancy also increase. CRMS is able to solve these problems and improve the productivity. CRMS can create study records, enroll patients for transmission to Epic, create a bill coverage analysis for the study, provide detail about the study to the clinical and translational research center, access IRB documents, and track the progress of study approval, request and determine charges to investigational drug services support, request contract help, and processing from the Office of Clinical Trial. CRMS is also helpful by providing a centralized place to house all the research-related information and make sure clinical trial always have the accurate and up-to-date information without redundancy. CRMS improve research workflow, which made the clinical research informatics scientists work more efficiently and generate more solutions related to the healthcare area to improve the patient outcomes. The third domain, consumer health informatics, focuses on the health literacy of consumers. One of its applications, Microsoft Healthful, is a program for people to access and share personal health information online. Microsoft Healthful educates the patient to have a better ability to manage and protect their personal health records. It includes personal identity, contact information, medication history, allergies, and immunizations. It is created by Microsoft in October 2007 to store and maintain health and fitness information. It allows information to be exchanged between selected devices. In June 2010, it expanded its service beyond the United States to include the United Kingdom. It is helpful in organizing family health information, preparing for doctor visits, and providing information in unexpected emergencies. Microsoft Healthful can give users record history, document allergies, and lab result checking, connect to other apps and devices to promote better quality of life, share patient information with providers. It also increased the autonomy of patients over their personal health records, which increased the patient's engagement, help patients maintain themselves in a healthier lifestyle by connecting to fitness apps and devices. Healthful is very comprehensive. It provides all features in supporting users' healthcare experience, which is helpful in sharing health information, improving care coordination, and promoting the privacy of patient information in the U.S. healthcare. Engaging patients in increasing their responsibility toward their own health is very important in order to promote a better healthcare outcome. The fourth domain, public health informatics, focuses on the surveillance, prevention, and preparedness on the public health to promote health, wellness, shared decision making, and computer engagement One of its applications, Geographic Informatics System (GIS), is a tool to analyze data based on geographic to track infectious disease and public health disaster to promote the population health. The first known use of the term Geographic Informatics System was by Roger Tomlinson in the year 1968 in his paper, A Geographic Information System for Regional Planning. By the end of the 20th century, the rapid growth of various systems have been consolidated and standardized on relatively few platforms, and users were beginning to explore the use of GIS data over the Internet, requiring data format and transfer standards. More recently, a growing number of free open-source GIS packages run on a range of operating systems and can be customized to perform specific tasks. GIS analyze spatial information and add the data in maps. Use location as the key index variables. Layer the data in the GIS map against different environmental variables. GIS also enables researchers to understand patterns and relationships more easily to solve public health information issues, prevent both biological terrorism and natural infectious disease threat before happening, and set up plans for coming public health problems. GIS can help to locate the larger concentration of where the disease is happening and notice local politicians and religion groups to provide education for the neighborhoods to prevent this kind of disease from happening again. Thus, GIS will be effective in reducing health disparities in different neighborhoods to promote the population health in the future. The last domain, translational bioinformatics, apply biological discovery to the clinical setting. One of its applications, Watson, is a question answering computer system, which has access to countless structured and unstructured information. It can be used to utilization management decision in lung cancer treatment by searching answers in different resources. Watson reduced the gap between the basic scientific discovery and clinical practice by searching the answer in its database and turned the data into knowledge to build practice health and provide precise treatment for the patient. In February 2013, IBM announced that Watson software system first commercial application will be for the utilization management disease in non-cancer treatment in conjunction with health insurance company WellPoint. Watson can surface insight from massive amount of personal and academic health data, suggest treatment plans to rare disease, support physician making a better choice for the patient, provide a framework to learn, connect, and store the data for the future. Watson is also able to store the data generated from patients to be used as a future reference to solve human disease, and it allows newly generated knowledge used by a variety of stakeholders, which is effective. More importantly, Watson is able to figure out the cause of disease and provide several treatments by analyzing thousands of resources in seconds. Watson has also described as a game changer because it is able to save countless money and time for the future of U.S. healthcare system. That's all I have for each domain. You can watch the video and click the link that were provided in each pages for more information. Thank you for watching this video. I hope you have a better understanding of each domain now.